Hello YouTube, RJ. Today we're going to be talking about antenna tuners. Now this video is one that I've been planning to make for quite a long time. I've thought it through my head quite a bit, but a commenter from one of my previous videos kind of led me into going ahead with this video and getting it done. I've been planning to do it a long time. I don't know why I just keep putting it off, but this pushed me a little bit to do it. And I think it's because it's kind of stirs up a little controversy from time to time, because there are people that are in basically two camps when it comes to antenna tuners. And this video is about, what does an antenna tuner do? Does it really tune your antenna? Spoiler alert, they don't tune your antenna. But now many people believe, and they'll come at you with ARRL says this. Recently some of the comments were, this has all been figured out. All these people say this, and that it does tune your antenna and it makes your antenna resonant. So when I say tune your antenna, what I mean is there are people, and it's not just this viewer that mentioned this. I've been planning this video for a long time because I had so many hams tell me this. It's almost a myth, but I don't think it's a myth. What I think it is a misunderstanding of sometimes technical literature and technical papers will say something, and I'm going to cover this later in the video. Some people read it in a way that makes them think this is what they're saying, and they're not really saying this. So the first thing to point out is the big debate is whether, when you put an antenna tuner in your system, you got your radio, your antenna tuner, and your coax and your antenna, and you tune, your antenna is not at residence, and you tune your antenna tuner, there are people who believe that the antenna and coax changes because of the tuner. It makes a conjugate match that causes the antenna, coax, and antenna, the antenna system, to be resonant, meaning it is 50 ohms resistive, and that's all. There is no inductive or capacitive imaginary impedance in it, and it's just like a perfectly cut antenna that's resonant at this frequency, and it's going to have no reflected energy back because the impedance is a perfect match, and it's just as good as having an antenna cut just the right length. That's what they believe. The truth is, an antenna tuner cannot modify your antenna. The only thing that can make your antenna resonant out there is if you modified the antenna. The antenna tuner does not change your coax or your antenna's impedance at all, period. That's not what's happening. What is happening is your antenna tuner matches 50 ohms with your radio, makes your radio see 50 ohms, even though it's really looking into some other impedance on your antenna. They used to be called transmatch. They weren't antenna tuners. Antenna tuner got stuck on there at some point, and I don't know why, because they don't tune anything. What I'm going to do today is we're going to jump over onto the ham bench, and I'm going to do a little experiment which will bring forth and will demonstrate how they actually act and what they actually do. Now, I'm going to show you the SWR from the radio to the antenna tuner, and from the antenna tuner to the antenna. And what we're going to do is start out intentionally with a mismatch system where I tune my radio to a frequency my antenna is not resident on. We're going to show you what's shown on both SWR meters. And then we're going to tune. We're going to engage my tuner then. We'll go from bypass to where the tuner's doing its job. And I'm going to show you what the radio shows the SWR is. And I'm going to show you if there is any SWR and what it is between the antenna tuner and the antenna. Now, if the antenna tuner is truly modifying your antenna's impedance and making it resonant, you would get no reflected energy back. So therefore, you wouldn't have, your SWR would be 1-to-1. I don't want to say you wouldn't have SWR, because you would. That's a measurement. You wouldn't have any standing wave. You would have 1-to-1. Your minimum to maximum voltage on your transmission line would be the same. Let's jump over the bench. Let me show you that. But don't run off after that, because I'm going to come back and show you a lot of information. And one of them is going to be the people that claim that ARRL says something. I'm going to show you that's not true. They're misunderstanding what ARRL has to say. I'm going to talk about where I think this comes from and what's confusing people and why people might think this is what's being said sometimes. So we're going to truly stop the BS on this. This is antenna tuners, no BS. All right, here we are on the bench. I have tore my ham stuff completely apart, rewired everything, made a mess, slid monitors over. Got a lot of dust up here. I'm going to take everything off, clean it, put it back together. But did this so I could demo this for you. What we have is we have my FT710. Got it up on the monitor to get you big enough to be able to see the meter good. It is now, amplifier is not wired in. FT710 goes straight into my home built antenna tuner, comes out of antenna 1 output, actually input, I guess, antenna 1 input to the Dahua meter over here. Got the little DJI Pocket 3 over here recording, so you can see that. You can see it on the overview camera, but you're not going to be able to see the needles well enough. So I put the little Pocket 3 here really in on it where you can see the needles. Coming out of the Dahua, we go directly to my 80 meter full wave loop. And so the experiment is this. I'm putting my tuner on bypass antenna 1. So what my radio is now running in, straight through, and out. It's not, no tuning is going on. It goes out through the Dahua and out to the antenna. So I've got a SWR meter on the 710 Yaesu up here, bottom scale. Anytime I transmit, it shows me SWR. Currently it's receiving, and so you see an S signal. So I'm going to turn the audio down so we don't have to listen to the noise there. Nothing's on the band. I'm at 3.7 megahertz. That is well below the resonant area of my antenna. I tend to work 75 meters up the band. So I've tuned it down to get off of resonance. I've put it on CW mode so I can get some steady output. The power is about 16 watts, so I've turned it down quite a bit. And we are bypassing the tuner, so we're strictly just running right through that, right out to the antenna through this meter. So here's what I want to do. As we discussed, we expect to see some SWR on both meters. They should be the same. They won't, I'll tell you now. These two meters have never read exactly the same. Don't know why, don't know which one's more accurate. I think the Dahua is pretty accurate. It seems like the Yaesu at the lower power here tends to be kind of reads a little bit high in my opinion, but we'll see. So anyway, let's see. Let's take a look right up here, bottom scale, SWR on the 710. Let's see what we see when I key up. Okay, I would say that's a 2.5 to 1. I hope you'd agree. Solid, at least 2.5 to 1. Now let's jump over. Everything's the same. Let's look at the Dahua. What does it read? Okay, it's reading about 1.923, somewhere in there. A little bit over 1.9, almost 2. Let's do it again. Same thing, repeatable. How much wattage are we putting out? Well, about 16 watts. Reflected about 1.6 watts. That is the antenna tuner out of the loop. So I am definitely not resonant. My antenna is not precisely 50 ohms with 0J. So with that in mind, let's switch over and put the antenna tuner in line. And what I want you to see is, turn the audio up just a second. Sure, nothing there. Now, I went ahead and, of course, ahead of time, to keep from wasting time, I've tuned this frequency with my antenna tuner. So what I'm going to do is I'm going to reach over here and turn off, or actually what I'm going to do is put the Dahua into PEP mode, which will, because there's no power being fed, I have the little plug for the PEP and for the light unplugged. It just basically will shut that thing down. It won't display anything. And so I want you to focus now on, we've got a tuner, we've tuned our antenna, right? We've tuned it, we've made those adjustments that some of you believe makes changes to the antenna, some of us don't think it changes the antenna. So let's see what we get on the Yaesu now. Pretty flat. Pretty much 1-to-1. I mean, it looks dead one to one. So now my radio sees a 1-to-1 match. It thinks my antenna is perfect. Now I would argue it doesn't know about the antenna, it's only seeing my antenna tuner. But let's move forward and say, okay, we know what to expect. Those that believe that the antenna tuner somehow or another changes and makes your antenna and feed line all resonant, changes your antenna system to be resonant on this frequency, so it's a perfect match and all the power goes out and none reflects back. In that case, we should now see a 1-to-1 on the Dahua meter when I enable it. Because your antenna is happy, it's at that impedance, it just radiates the power, it doesn't reflect. There is no mismatch anymore at the antenna is perfect. So let's see, which one's right? Are we going to have reflected power coming back to us? Yes, we are. Where's it at? It's right where it was. Except for one thing, you will notice a little bit more power coming out. Notice that? I'm getting about 18, almost 18 and a half. No, 19, pretty close to 19.
And my reflected is a little, it's like a 1 point, what, maybe 7. So my power went up, forward and reflected. Both powers went up. Why is that? Well, let's think. If my radio is now matched to this antenna tuner and is seeing a perfect match, the power transferred between the two is more efficient, and I'm getting more power transferred into the antenna tuner, which then means more power will leave my antenna tuner and go out to the antenna. Well, since more power is going to go out to my antenna at this point, even though it's just a little, that means that my reflected power, if the SWR does not change, well, let me not say SWR, if the impedance match doesn't change, which equates to the ratio of the SWR, if the impedance match hasn't changed and I'm putting more power out, more power is going to reflect it back, the same ratio. So a little bit more forward is going to give me a little bit more reflected, and that's exactly what we're seeing. My radio sends power to the antenna tuner and nothing comes back from the antenna tuner. There's no reflected power. There's no standing wave. There's standing wave on the coax and the antenna, but there is none on my radio. Let me turn it back to bypass. What happens? The same thing over here, except my power goes down a little. But over here, now I'm seeing SWR on my radio. So I hope that kind of puts it to rest that your antenna is not being changed. You have not changed the mismatch at your antenna and your feed line. It's still mismatched. You still have everything going on you did without the antenna tuner, except your radio can effectively put power out now. And there's no harm to your radio. Nothing. Your radio has no idea. It believes your antenna is a perfectly tuned antenna. So now let's jump over the bench because we're not done. Now let's talk about what happens to this reflected power. Is it lost? Is it gone? Do we always have to have a resonant antenna, or we can't get out very well? Let's talk about what happens to that power.
I hope that experiment kind of gave you something to think about. I want to address a number of things, including what happens to that wasted energy. But first, I want to go into the why does everyone think the ARRL says this? Why does everybody think that all these people are telling them this? First, let's take on the ARRL. If you believe the ARRL is telling you that, then you've probably never sat down and read this PDF right here that ARRL put out called Antenna Tuners Making a Match. Now, I'm not going to read this whole 3-page document to you, but what I am going to do is I'm going to tell you what it has to say, and I'm going to use a little bit of the graphics from it to explain. But I'm going to put a link up in the description. You'll find a link to this public PDF that they put out on the internet so that you can go read it in its entirety and make sure that I am not misdrewing what this document says, okay? So they go into a lot talking about antenna tuners and what they're for and all about them, and the manual tuners, automatic. They talk about the benefits of putting an antenna tuner at your antenna. But what I've done is I went ahead and made a blow up of one little section that is really to the core of what we're talking about here. So let me bring this up where you can really see it. And they're explaining exactly what I just demonstrated to you. They're saying that here we have a radio that's a 50 ohm impedance. We've got 50 ohm impedance line, but our antenna is not resonant. It's 108 ohms. And so that gives us a 2.5 to 1 SWR. And then it explains that if you put a tuner in between your transceiver and this antenna that's still 108 ohms, and you tune the antenna tuner, you can get a 1-to-1 match with your transceiver. But you still have that exact same 2.5 to 1 SWR. Your antenna impedance did not change because of this tuner. So in one simple little diagram, they tell you what they believe happens. You are matching the impedance of the antenna to 50 ohms on this port. There's 2 ports of this antenna tuner. You'll have multiple antennas on most antenna tuners, but let's just imagine you've got one antenna connector and one transceiver connector. You're going to have at this port whatever the impedance of your antenna is. Once you tune the antenna tuner correctly, this port is going to look like 50 ohms to this transceiver. And so it's happy, and it believes it sees this as its load. It has a 50 ohm impedance load. It's happy. It transfers its energy to this tuner effectively. The antenna tuner does not make any changes to the impedance of your coax and antenna whatsoever. Explains right here. With an antenna tuner in line, the radio has a 50 ohm impedance matched to the antenna system, and it sees a 1-to-1 SWR. This antenna system is one of the hang-ups. Some people consider an antenna tuner part of your antenna system. Some people do not. So when someone says your radio has a 50 ohm impedance matched to the antenna system, they don't mean this antenna system has become 50 ohm. It's resonant. They're not saying that. They're not saying that at all. They're just saying that the radio sees a 50 ohm impedance as its load. They're considering this to be your antenna system. So now it has a match of 50 ohms to your antenna system. It did not make this antenna resonate. You still have SWR, you still have losses. The radio has 50 ohm impedance matched to the antenna system, and it sees a 1-to-1 SWR. Now it can transfer all its power. Note, however, that the mismatch in the higher SWR still exists between the tuner and the antenna. So ARRL does not believe that it tunes your antenna and makes your antenna resident and effective. It doesn't. They don't believe that. This document clearly shows that. It's how people read comments about this, where they say things like it made a 50 ohm match to your antenna system, and you're thinking, well, my antenna system's now, Another one that comes up is when we have two circuits in a radio, and one is a 100 ohm, or let's say it's 50 ohms, and this amplifier it's connecting to is 200 ohm input impedance. Okay, so we got 50 to 200. We got a massive mismatch. We can't transfer energy very effectively to that amplifier. We will put something in the middle. It might be a transformer, or it could be an inductor and a capacitor set up to transform the impedances, meaning that the first circuit will see 50 ohms load, and the amplifier will believe it's being fed by a 200 ohm source. And so both of them will be happy. And we say that it transformed. We'll say that this circuit transformed the impedance. That doesn't mean it changed the impedance of the circuit. It means it worked like a translator between the two of them to make them happy. Okay, with that out of the way, that should answer where people get this, where they think ARRL says this and such. Let's move on to what happens to the energy. Do we just lose whatever gets reflected back from your mismatch? No, not really. We have losses, definitely. So let me show a little diagram I did up here and explain it a little. You have 100 watts coming in to your antenna tuner from your transceiver. And that 100 watts, we're going to say there's no losses in your antenna tuner. There is very little normally. 100 watts forward, the red, goes out your transmission line to your antenna. Now, no transmission line is lossless. We do not have superconductor coax yet. I'm waiting for it any day. There is some resistive losses in this line. So while we send 100 watts forward, let's say that our antenna transmission line took a bite of 10% of our signal out. These numbers aren't realistic. They don't match with the SWR or any of that. I'm just using this as an example to make it clear. So 100 watts goes out, but when you get to your antenna, you only have 90 watts of that left. You lost 10 watts in your transmission line. You have an SWR 2.5 to 1, so not all of that energy is going to make it in your antenna. When it hits this antenna, which is at 108 ohms, you're going to cause a reflection back. And let's say that you reflect 10 watts back. So now 100 watts, the red arrows, end up being 90 watts when they get to the antenna. And of that 90 watts, 10 watts gets reflected back because of the mismatch. So now the blue, we've got 10 watts making its way back through the transmission line. But remember, the transmission line has losses. We lose 10% of everything going through it. So that second trip takes a bite out of that. And by the time we get here to the antenna tuner, where we're going to turn around and be reflected right back, that's why your receiver on the other side doesn't get any of that energy. It gets reflected right back through the transmission line, but by the time it gets to the tuner, it's 8 watts. You've lost some in the line again. So that 8 watts gets reflected. There's some losses in the reflection itself, but we don't want to get too complicated. Say 8 watts makes its way through here. Well, if 10% is going away, 0.8 watts. So now we get 7.2 watts back to the antenna. A good chunk of that, about 90% of it, makes it through the impedance match into your antenna. But guess what? 10% gets reflected back. And this process continues until all of it's used up in either the losses in the coax as heat or it goes out the antenna. So you don't just lose all of it, but you do slowly lose some of it. You do take a bite out of your transmission by being mismatched. And the worse your mismatch is, the worse this is. The worse the mismatch, more power will go through it and more times it'll go back and forth. It's always best to have a resident antenna so that you transfer the energy straight through effectively and right out the antenna. Trust me that the energy is added back into your signal. You're not losing all of it. The only real losses are your losses in your coax. So because of that, good coax makes a big difference. That's why the better the coax, the better off you are. The higher the SWR, the more losses in the coax you're going to see in the reflections. The better the coax, the less. And that means eventually more of the energy will make it out of the antenna. So that's really it in a nutshell. I want you to come away with, you don't lose all the energy that gets reflected, but you do want to have the best match on your antenna you can. And we know you want to have a good match with your radio. Our little example showed that we gained a little power when we matched, and we don't have very much SWR to deal with. And just changing with an antenna tuner that little bit, the energy change. And now imagine that was with me putting like 16 watts out of the radio. If I'd have been putting 100 watts out, or if I'd had an amp and putting out 600 watts, imagine the increase we're talking about, the differences there would be. So a good match with the radio with your antenna tuner is very, very important. This does not mean that antenna tuners are not good devices and they're not needed. So with that, I hope this clarifies it a little bit. I hope you enjoyed the video and learned something. But most of all, I hope to see you in the next video.